These are the 5 most important space missions in the next 10 years that could give humanity the keys to the solar system. Number 1. The Artemis moon missions. To understand Artemis, you have to change your perspective. Imagine the moon isn't just a rock, but the 8th continent of Earth. For decades, we've treated it like a tourist trap. Visit, snap a photo, leave. But Artemis is different. Think of this as building a permanent bridge. If Apollo was a weekend camping trip where you packed all your own food, Artemis is like building a high-tech research station in Antarctica. You don't go there just to say you did it. You go there to stay, work, and learn how to survive. A critical objective, arguably the most important one, is the hunt for lunar ice. We aren't just going back for rocks, we are going for water. Scientists believe deep, shadowed craters at the lunar poles hold massive reservoirs of frozen water. Securing this ice is the key to everything. Water is the oil of the solar system because it can be split into hydrogen and oxygen, rocket fuel and breathing air. To get there, NASA is using the SLS, Space Launch System, the most powerful rocket ever built. The crew travels in the Orion capsule, their life support home, but once near the moon, they'll meet up with a specialized SpaceX Starship. This massive vehicle acts as a moon elevator, taking them from orbit down to the dusty surface and back. We are in the thick of it now. Artemis II is scheduled for early 2026. This is a massive milestone where 4 astronauts will fly around the moon. They won't land yet, but this is the ultimate high-stakes test drive to ensure that the life support can keep humans alive in deep space. Then comes the main event, Artemis III, targeted for 2027 or 2028. This historic mission will see mankind return to the lunar surface. They're targeting the lunar South Pole, a dramatic landscape of deep craters that haven't seen sunlight in billions of years. From 2028 through the 2030s, we move into the settlement phase, building the gateway, an orbiting station, and a permanent base camp on the ground. If Artemis succeeds, it turns the moon into a cosmic gas station. Right now, hauling fuel up from Earth's deep gravity well is incredibly expensive. But if we can harvest fuel on the moon where gravity is weak, we can gas up in orbit. Instead of hauling heavy fuel all the way from Earth to go to Mars, we stop at the moon first. Success here means the solar system is suddenly open to explore. Number 2, the Europa Clipper mission. Next up is a mission into the most hostile radiation environment in the solar system. The Europa Clipper is being sent to answer the ultimate question, are we alone, by visiting Jupiter's moon, Europa. On the outside, Europa looks like a giant, cracked cue ball of ice. But scientists are almost certain that beneath that frozen shell lies a global salty ocean containing more water than all of Earth's oceans combined. The Clipper is a flying laboratory the size of a basketball court. Its job is to fly through the intense, invisible death fields of Jupiter's radiation belts. This radiation is so strong it would kill a human in minutes. Clipper has to brave this environment to see if that hidden ocean has the right ingredients to cook up alien life. Launched in late 2024, the spacecraft is currently performing gravity slingshots, whipping past Mars and Earth to gain speed. It arrives at Jupiter in April 2030, but here's the trick. It won't orbit Europa directly because the radiation would fry its electronics in days. Instead, the spacecraft will orbit Jupiter and perform 49 high-speed dives past the Moon from 2030 to 2034. It will dive in close to scan for hidden lakes inside the ice shell with radar, then retreat to safety. Success here would be the biggest discovery in the history of science. If Clipper finds the ingredients for life, water, energy, and organic chemicals, it proves Earth isn't a fluke. It means life might be a standard feature of the universe. Number 3, the NASA Psyche mission. Most asteroids are boring rock or ice,
But 16 Psyche is a 140-mile-wide metallic potato. Scientists believe it is made almost entirely of iron and nickel. The leading theory is that Psyche is the exposed heart of a dead planet that was smashed apart billions of years ago, leaving only the metal core. NASA is sending a spacecraft to check it out, but the implications go beyond science. This is the first concrete step toward asteroid mining. While NASA's goal is science, they are effectively doing the prospecting for the rest of us. They are heading to a rock that, if theoretically brought back to Earth, is valued at $10 quintillion. That is enough money to make every single person on Earth a billionaire. The ship is currently cruising through deep space. It has a big date with Mars in May 2026 for a final gravity assist to sling it toward the asteroid belt. The real show starts in August 2029 when it arrives at Psyche. For 2 years, until 2031, it will orbit the asteroid using a gamma-ray spectrometer, essentially a chemical X-ray, to map exactly what metals are in the ground without ever touching it. So, why are we going to Psyche 16? First, it's a time machine. We can't drill to the center of the Earth, so studying this exposed heart is the only way to see what the core of our own world looks like. Second, Psyche is testing the mining tech of tomorrow. The spacecraft uses solar electric propulsion, high-efficiency engines that use electricity to push the ship. This is the exact technology future space tow trucks will need to haul heavy metal. Success proves we have the engines, communication, and mapping tools to turn the science fiction of asteroid mining into a reality. Number 4. The Orbital Reef Space Station. For 25 years, the International Space Station, ISS, has been our home in the sky. But it's getting old. In 2030, NASA plans to retire it by crashing it into the ocean. Replacing it is Orbital Reef. Think of this as a business park in the sky. Built by private companies like Blue Origin and Sierra Space, it is one of the most ambitious commercial projects ever attempted. Unlike the cramped metal tubes of the ISS, Orbital Reef is modular. It uses inflatable rooms that launch folded up and then pop open in space. This provides massive amounts of room for sleeping quarters, labs, and even tourism. The first modules launch between 2027 and 2029. The goal is to have the lights on before the ISS goes dark in 2030. However, there is a realistic gap risk. If the ISS is destroyed in 2030 and Orbital Reef or competitors like Axiom isn't ready until 2032, humanity will have no home in orbit. That race against the clock defines the next 5 years. Once fully operational post-2032, it becomes a hub. It's designed to host a crew of 10 initially, but can grow much larger as more tenants move in. Success here means space is finally open for business. We move from government astronauts to a true space economy. Drug companies can use zero gravity to grow perfect crystals for new medicines. Tech companies can manufacture flawless computer chips. Movie studios can film in actual space. Crucially, it ensures the West keeps a foothold in orbit. If Orbital Reef fails, the only station left in 2030 might be China's Tiangong. Orbital Reef is the first step toward working in orbit being a normal job, just with a much better view.
Number 5. The Dragonfly mission. If you think drones are cool, wait until you see Dragonfly. This isn't just a camera drone. It is a car-sized, nuclear-powered flying chemistry laboratory headed for Saturn's giant moon, Titan. Titan is the most intriguing, bizarro Earth in our solar system. It is the only moon with a thick atmosphere, clouds, and rain. But the rain is liquid methane, negative 290 degrees Fahrenheit, and the sand is made of frozen organic grains. Dragonfly is going there to answer one massive question: how does chemistry become biology? Titan is covered in the same complex organic molecules that existed on Earth right before life started. It is essentially a planetary-scale factory for pre-life ingredients. Dragonfly launches in July 2028 and endures a 6-year cruise, arriving in 2034. Because Titan's atmosphere is 4 times thicker than Earth's and gravity is weak, flying there is actually easier than it is here. Once it arrives, it will parachute down, release from its shell, and fly under its own power to land among the dunes. From 2034 to 2037, it will perform a series of great hops. Every 16 days, it charges its nuclear battery, takes off, flies a few miles to a new geological site, and lands. Then it uses drills in its landing skids to suck up surface material and analyze it in an onboard lab. If Dragonfly finds amino acids or complex proteins in the ice, it gives us a direct window into our own past. It allows us to study the soup of ingredients that created life on Earth 4 billion years ago. It also changes how we explore. Rovers are slow and get stuck in sand. Dragonfly proves we can explore entire worlds by hopping over the obstacles. If this works, the future of exploration isn't driving, it's flying. Don't forget to like and subscribe so we can bring you more videos like this one.